is good? Any exciting stories from the weekend?
Dude, Hillary has like some sort of disease. You saw the video, we all saw the video, now it's confirmed.
She was unconscious, man.
She was unconscious.
Her feet were being dragged.
Yeah. Now it's been confirmed, man. Did Trump start attacking?
These are discussing.
He said he cares for her and that he hopes she gets better. Playing the game.
The discussion about politics is very dangerous. So I try to stay away from it inside a class setting. If you want to discuss politics with me, you have to come to my office. We can discuss politics. But I think political discussions are important. I think all should partake in that on the outside of class. Because it's going to affect you, right? I mean, you all are going to be affected by everything that's happening today more than my generation. So you should all take part in it. Especially global warming, if nothing else. It's a huge issue. It will certainly impact all of you. I used to actually give since we're talking about it, I used to give a project on process economics of alternative energy. So essentially students were asked to compare the cost of solar versus cost of gas or cost of oil or fracking. Economically, keeping only hard numbers and see what comes out on top. How many of you would find a project like that interesting?
Dude, raise your hand, man.
What about the rest of you?
Raise your hand, come on.
Is it that the idea of project doesn't appeal to you, or is it the specific project doesn't appeal to you?
The idea of doing project.
What would make the idea of project, what would make project appealing?
The grade that replaces
Yes, I can't do. Worst quiz I can do.
2.
Sorry?
2.
2 worst quizzes?
That's what we did last year.
No, we never. We had 2 different projects that replaced the 2 worst quizzes. Yeah.
Do like a team project, see who can complete it the cheapest.
And then, but then do what?
Materials.
I'm happy to do that, but if nobody participates in it, how do what incentive do I give you all? Now, of course, it's a
Extra
dictatorship,
credit.
right? I can just say it's a requirement and be done with it.
Extra credit.
What's the points to your lowest test?
But usually,
Yeah.
I try to, come on, I told you my rule number 1. I told you all why I became a professor, right? So I get to talk to you all for the 15 minutes. Don't take away all the hard work that I put into this, all the blood and sweat I put into this. You're making that all go waste. So yes, I can replace the worst quiz. Will that make it more appealing to those of you who were not attracted to it in the first place?
2, yeah, 2.
Place 2.
What?
Place 2.
Yeah.
Now remember, okay, let me put it this way. I can replace 2, but then the expectations from you, of course, correspondingly increase. Right? So,
10 points to
very
your,
risky, sorry?
10 points to your lowest exam score.
20.
5 points. 5 points.
Bro.
That's like replacing the worst quiz.
Is it?
Yeah, because the quizzes are worth about, I don't know, 20 points, and exam is worth 40 points. So each quiz will be worth about, I don't know, 8 points.
Make lowest exam score replaced with average of exam scores.
Why don't I just give an A to everybody and be done with it? That's what it takes to get an applause.
You got it.
Finally figured out, yeah. I was pretty early, actually. I can make the same promise every day. And eventually not honor it.
8 total.
Drop our lowest test grade.
Alright, we're talking about politics anyway, right? I'll just say I didn't change my, I didn't lie. I didn't change my mind.
No.
What's it?
Alright, so this is serious stuff. I think this is going to be an interesting project. So, what I will do is I will make this voluntary. So, if you don't want it to replace your worst quiz, don't do it. In which case, you will not have your worst quiz replaced. And if you would like to do a project, the project score will replace your worst quiz score. Okay, does that sound fair? Yeah. That's everybody wins. Don't want to do it, don't do it. If you think you'll get straight A's in all quizzes, you don't have to do it. Although as far as I'm concerned, I don't know why you wouldn't do it. Remember, you're not here to just to get A grades. In the end, if you do this quiz, if you do this project nicely, you'll learn so much. Who knows, someday you might be interviewing for a job. $1 million job, and they might start talking about alternative energy, and if you don't know what you're talking about, you're not get a job, right? Alternative energy is there to stay, right? In fact, sure. I don't even know what. It will not be called alternative energy, hopefully. It'll just be called energy. And hopefully soon it will be called the cheapest form of energy. Right? But there are still interesting questions about it. Like, is it sustainable? Is solar sustainable? Depends on how much material you consume, right? But yeah.
So how many people would be in a group, and like how many would you have to include? How many different?
Logistics, we can figure it out later, right? How many would you like?
4 to 5.
Sorry?
4 to 5.
Well, the important thing would be like how many different energy sources would we have to include in the report, and then you of course had one person per.
Yeah.
What did we do before or after last quiz?
I usually make it due on the day of the final exam.
Can you explain the project again?
I haven't decided the project.
Um,
We're deciding together. Yeah.
I heard a rumor that Priuses are not as good for the environment as they are.
What is not good? Oh, Prius is not good for the environment.
Because of all the materials that are consumed, and then once they're gone, then they're really hard to like break down or recycle.
Yeah, exactly. That's what I was saying about solar. It's sustainable. What about the materials you're consuming in the solar? What will happen to it? Like, today, we never thought of TV screens. What happens to that? We never thought of iPhones. Okay, let me give you a very classic example. How many of you drink that coffee thing? Not the Nespresso, the other one.
Keurig.
Keurig. Because normally it comes in plastic. Right? Initially, when the guy who started Keurig, he would not thought of this as an environmental problem. The amount of plastic that thing generates is crazy. It's not recyclable. It's actually quite a big problem. So sometimes the law of unintended consequences. You just don't think of stuff in the beginning. But an interesting calculation. I've never seen anything like this. If you can find out how much material you consume to make solar panels, figure out how much waste you generate over the next 100 years. Figure out how much material you have in here right now available. Where is the rest of it going to come from? Also, what about the impact of mining on the environment? Right? So I think it's a very interesting, and also these kinds of projects are fairly open-minded. Hopefully open-minded, but hopefully also open-ended. Yeah, do what you would like to do. I think of this as an opportunity for you to teach me something. If I learn anything from it, I give you 100%. If I learn nothing, then I just have to see how it is. So yeah, But I'll give you some instructions, a little bit more than what I'm telling you right now. So yeah, so that's what our deal is, okay? We're going to make it voluntary. It will replace the worst quiz. We'll have 4 to 5 students, teams of 4 to 5 students each. Pick up at least 3 sources. Look at the economic impact of each of those. In fact, I think it would have been simple. I would say look at any 3, but if you want to compare only 2, pick only 2 to compare. The third one just describe. Talk about it at least qualitatively. So 2 I want quantitatively. And solar would be probably the one which would be easiest to get the data on. I would say the straightforward sense, compare solar to coal or solar to gas. And look at the cost versus environmental consequences. If you can quantify it all in terms of the concepts learned in this class, it will be good. If not, just put some numbers, argue your case or what you think is better, and then put in the side things like long-term impact of solar. Right? Sound interesting? Yes? Fracking would be a good one too, I guess. Because it's so relevant right now. You don't want fracking?
What?
You like fracking or you don't like
I
fracking?
hate fracking
Hate fracking. Why?
because of the environmental damage and just overall about the water treatment and stuff. People living in the area.
So you try about fracking. Also, interestingly, it's impossible to really remove politics from the equation. Because sometimes there are 2 states right next to each other. Fracking is allowed in one, the other fracking is not allowed. Right? And that's just so strange. Because people in whom the fracking is not allowed, There's 3 other people causing environmental damage and becoming rich off it. But they can't do it. It's because they live in that state. Can you tell me an example of these 2 states? New York and Pennsylvania, I think, are 2, right? I don't know. There are 20 others. So yeah, in some sense, you can't really remove politics from the equation. Okay. Any questions about this? I'll probably write something out. Any questions? No? All right, so y'all are super excited?
Dude.
Why not? Why not? You're not excited? Why? Come on. I don't know what you do with all the garden. What do you do? How many are applying to? Apply to that.
Problem solved.
Bring me a list, I'll reduce the list. I'll put it down. What else do you do? What? Okay, all right, so let's come back and talk about what we were starting discussing last time, which was costing, right? Remember we started talking about costing, and we said, shh. We said we're going to talk about costing, and we started talking about how, if you're going to cost a plant, we have to kind of design the plant. And you know, you don't just start designing the whole plant at time 0. If you're thinking about starting a plant for something, you don't suddenly design the whole plant and then cost it and then look at economic analysis. You start with something simple. So like today, let's just start by essentially considering a very simple plant. Well, not simple, but a plant for making benzene. Okay? So let's say that you have toluene, and what you're going to do is you're going to react toluene with hydrogen to make benzene. Okay, and what is toluene? Toluene, I guess, is C6H5 or CH3, right?
Yeah.
Okay, so plus H2, that you're going to have to put an extra oxygen to get, I mean, you're going to have to put extra hydrogen to make benzene out of it. So this will give you C6H6. Okay, plus what?
CO2?
Sorry?
No.
Okay, plus CCH4, right? Yeah? All right. And let's say, so this is of course the first step, right? And now, of course, once you write a reaction, you have to figure out if it's energetically favorable, right? You can do some thermodynamics calculations, figure out this reaction will never occur. After we figure that out, now of course you know that this will occur because this is how actually benzene is made. This process is called I don't know if it has a name, but anyway, I guess it's reduction, right? It's reduction of toluene to get benzene. So let's say that you want, for your design, let's assume you are producing 10,000 kilograms per hour. And we want to start with a very simple block flow diagram for this process, okay? All right, so first of all, you have to figure out how much hydrogen to put in. Assuming, so we're going to start 100% conversion. Now, we all know that you never get 100% conversion.
I think we need coefficients.
Sorry?
I think we need coefficients.
Oh, yeah, we need coefficient here.
Or
We're good.
is it good?
No, it's fine.
Oh, never mind.
Yeah, it's balanced, right?
So you said we're producing 10,000?
No, we are consuming, let's say, 10,000 kilogram of per hour of toluene. Question is how much hydrogen will be consumed and how much benzene will produce. Right? That's the starting point. You may also, you know, once you, of course, in addition to looking, how do you figure out this reaction is feasible or not?
The delta G?
Sorry? We can look at thermodynamics. You can also look at rates of reaction if there's any data. Because sometimes the reaction may be feasible theoretically, but practically may not be feasible. What do I mean by that?
Delta G?
Yeah? Because the rates of reaction might be so low, or the conditions for the reaction may be so outrageous that you will never be able to do it. Right? And this requires high temperatures, but the high temperatures are realistic, so it's okay. But if something requires 10,000 Kelvin, of course, that reaction is not feasible, right? All right, so yeah, let's do a quick balance to see how much we have hydro. So the molecular weight of this is what? 72, 77, 80, 92, right? Is it 92? Correct me if I say something that is wrong.
It's nice.
Sorry?
It's good.
Okay, 78, right, 16. All right, so this will be 10,000, so 10K times 2 divided by 92, right? Which is what about 50, something like 2,000, right? How much is it? Sorry, what do you get? 217? 10,000. Yeah, okay, fine, that's okay. The number here is actually. Okay, so right now we are just doing 100% conversion, so let's just assume that. Now, of course, usually what you will also say is that reaction chemistry will tell you that you probably have to run, you should run the reaction on hydrogen axis, right? Because if you run stoichiometrically, the rates might be too low. And if you're rate limited by hydrogen, you actually probably take it a little higher. So this particular balance that I'm seeing, they're putting in actually 850. So the stoichiometry requires 217. Kinetics tells you that you should run at 850. So basically, you can see you're running it at 4 times axis, right? 4 times what is required, 4x. All right. So how much of this you'll produce will be limited, of course, by how much of the toluene you're putting in. So that will be 10,000 times 78 divided by 92, which will be, right on the number from here, it's 8,200. And then, of course, there will be the remaining classes. Okay, so that's sort of the starting balance, right? Okay, so now let's see how do we convert that to a block flow diagram. So, of course, you need streams, right? You need streams to come in. So, the block flow diagram will have a stream for toluene. A stream for hydrogen. We're going to just write a block here for reactor, right? Let's just put a block there. Okay, so then of course you'll get gases coming up from the top, right? Which is probably light gases. And then of course you'll get liquid coming from the bottom. The bottom will actually, from this reactor, you'll probably have a water that is two-phase. So you probably have a separator here. You'll still get the gases out, liquid out from the bottom, and you'll probably feed that to a distillation column. Okay, where toluene will probably be recycled.
Damn.
I guess you can recycle it partly here. And then, of course, you get benzene from here. Right? And then there will be probably methane. You can actually combine these two. And actually, if you think about it,
Holy shit.
even this, once you have, there's a condenser here, right? So for a condenser, there might also be a light gas. So this is basically the block flow diagram, right? Where there's a condenser here.
Do you teach MEB?
Sorry?
Do you teach MEB?
No, why?
Just wondering. Think.
Huh?
Nothing.
Everybody teaches MEB because every course is MEB. Every course in chemical engineering, you do mass energy balance. Right? Okay, so that's sort of the elementary block flow diagram. Okay? Make sense? Yeah.
Why did you combine the steam?
Because they're all light gases, right? What else do you do with this gas? So yeah, what's coming from the top is all light gases.